Okay, we're going to conclude talking about the capital budgeting techniques by just covering some additional techniques that could be used or frequently are used in mostly larger companies, right? So, one of the things we have here is something called a modified internal rate of return. Now, the challenge with the internal rate of return, even though it's one of the most popular techniques used, is it is not applicable to many types of projects within the company. So the modified internal rate of return gets rid of some of the projects that just can't be answered with the internal rate of return. And I guess if managers want this percent rate of return as the answer, if they relate more to that kind of an answer, then this is a better choice. So essentially what it does is it converts the cash flows in the future and says, what would happen if I would reinvest them at a reinvestment rate? So it takes these future cash flows and moves them forward to the end of the project. It's what they refer to as the terminal value. So then we actually have two cash flows. We have the investment cash flow at time 0, and we have the terminal time value at the end. So since we also know the time frame, we know N, we have a present value, a future value, and N, we can solve for the interest rate. So this process, again, gives us a type of internal rate of return answer. So if you look at the modified internal rate of return, for project A, it's 17%, and for project B, it's 15%. We have a reinvestment rate of 13%. So again, this technique is going to perform better than the reinvestment of these interest rates. So you're going to get more of a rate of return to the company than the actual reinvestment rate for the company. The next technique talked about is the profitability index. Basically, this gives us, again, another picture that's very similar in formula to net present value, but it doesn't have the guarantee, if you will, in quotes, of measuring the change in wealth. But it does give us a little bit of a measure of the bang for the buck. So this looks at the present value, the benefits that the company gets, and divides that by the initial cost. So if this is going to give us a value that's greater than 1, it implies there's more benefits than there is value. In this case, you have 1.24 is the profitability index, 1.17 is for B. Both are greater than 1, and of course, A is, in this case, is better than B. And I might add that, again, that's not always the case that A is always going to be better than B, or that one project will always be better than the other for all of the techniques. It could be a mixed bag. The payback period gives us a very short and easy calculation, if you will, of how long it takes for us to get our money back. There's a lot of strengths and weaknesses. We'll talk about those here in a second. But one of the challenges is the payback method does not utilize the time value of money. So there is a discounted payback method that shows us if you find the present value of those cash flows, how long does it take to get the present values back? This gives us at least a time value number to consider. And so the strengths and weaknesses here of the payback method, again, it's a very simple method used by a lot of small businesses, but it gives us an indication of risk. It's easy to calculate, it's easy to understand. Again, time value is an issue. It does ignore any cash flows that occur after the payback period are ignored. And of course, how do you figure out what's an acceptable number? The management has a very subjective decision here, right? How long do we want to take to get our money back? And that will certainly impact our acceptance of projects. So we want to be very careful about what number we pick. And if we look at the numbers here for our projects, 2.5 is the payback for A, 2.76. A is better than B. 3.3 for the discounted versus 3.7. Again, A is better than B, but we don't really know what management's decision is. If management says, look, I want to get my money back in 2.5 years, the payback method will work, but the payback period for B is over that, so we would decline to do B. If we said we want to get our discounted payback is 3, then neither one of these projects would be acceptable. So some of the challenges that we have with projects, or one of the projects, is they refer to them as normal and non-normal cash flows. So the first thing I want to kind of mention here is when they say non-normal, it doesn't mean it doesn't happen. In fact, it happens quite frequently, especially in some manufacturing kinds of concerns or in mining, where you have large capital assets that from time to time may need to be rebuilt. So a normal cash flow is the typical kind of investment. You pay for something today, it's followed by a series of positive cash flows to the end. There's only one change of signs, right? Negative to positive. Non-normal means there's 2 or more changes in signs. So you have an outflow when you purchase, there'll be then a string of positive cash flows. And then for some reason or another, we have to rebuild. That year is negative. Then it will follow by some more positive cash flows to the end. So again, there's lots of manufacturing types, mining types of projects that might fit into these non-normal cash flows. The internal rate of return will not calculate accurately the internal rate of return for a non-normal cash flow project. So what happens? Here you see we invest $800,000, we receive $5 million, and then we spend $5 million. Basically just showing us a non-normal cash flow where there are 2 changes in signs. Every time there's a change in sign, there is a potential answer. So in this case, the answer could be down here around 25, or it could be out here around 400%. So obviously 400%, you will never find any projects that will get you a 400% rate of return. So again, the modified internal return will take care of the non-normal cash flow issue if we're interested in the internal rate of return kind of an answer. Another challenge that we have is if we have 2 projects that are mutually exclusive, but they have different lifespans. Since net present value is an additive process, projects with longer lives have a bias that they are more likely to be chosen just because they have more cash flows. So here we have 2 projects. T has a net present value of $4,000. F is 6,000, or 4.1, 6.1. So if you're doing a mutually exclusive project, we know here that project F would be selected. But is that the best project for the company? Again, the project F here has more cash flows, so it has an advantage. There are two techniques we can use for this, and the one technique converts the net present value into an annuity. So in this example, the annualized net present value for the 2-year project is 2.38, and for the 4-year projects, 1.95. So again, what we see here is if you annualize the benefit, A is actually better because I have to actually do A twice. The replacement chain is a more common sense kind of way to do this. We're just going to keep repeating projects. The challenge is I'm not very good at the programming to do some of the stranger kinds of combinations. But if you take this, we have 12.7. If you do project 1 twice, right, you end up with, if you do this project 4 times, how it does this, how my example does it, it takes the 2 lifespans and multiplies them. So we're going to do this project 4 times. We're going to do this project 2 times. If we do that, the net present value of A is 12.7. Net present value of B is 10.4. Again, A is better than B. Now, technically, we would really want to just do this one twice and do this one once. But there could be some strange kinds of combinations. What if it was 3 and 5? We'd have to do this one 5 times, and we'd have to do this one 3 times. So we'd go out 15 years. So again, this is just what we refer to as unequal life analysis. And finally here in our discussion of techniques, we want to talk about something called the economic life versus the physical life. How do we choose the lifespan of a project? So what we typically will do, maybe we take a project and we're forecasting that project maybe out as many as 10 years. Now, what is the optimal number of years to do the project? Now, we're not talking about ending the business or ending the project, but if we say, look, if the project is really good for 4 years, it's going to maximize its value. If we do it less or more than 4 years, the benefit that comes to the company is less. So it just says this economic life is that point when it is most economical to replace that project and then continue on from there. So it provides us with what we refer to as an engineering lifespan. So what we're going to do is look at what we refer to as abandonment value. What happens if you end the project? Well, let's say we thought we'd do it for 5 years, but what if we do it just for 1 year? We get 1 year's cash flow, and then we sell all the assets. So we have cash flows and we have an investment. We can calculate net present value. So, So in this example, we spend $100,000, and then here are our cash flows for the first 5 years. Now, what we have to forecast is what are the cash flows if we were to sell the project before the end. So if we do this project for 1 year, as I mentioned, we'll get $50,000 from doing the project. At the end of the year, we're going to sell the asset for $85,000, and we spent $100,000. So if you do the project for 1 year, the net present value is $17,000 odd. Modified returns 35, IRR is 35, profitability index is 1.17. But what if we did it for 2 years? The first year you'd get $50,000. The second year you'd get $50,000 plus the sale of the asset of $65,000. This increases our net present value to $30,000, 35% for IRR, 31.39. Notice that the modified internal rate of return went down. And again, the profitability index went up. Likewise, if we do it for 3 years, 4 years, and of course 5 years is our ultimate answer, what we thought this asset would last for 5 years. So what we want to do is we want to choose that net present value that maximizes the value for the company. In this case, net present value, $41,000, is the greatest value or benefit that this project is going to bring the company. So strategically, at the end of 4 years, we're going to replace this project, again, using the same assets, replace it technically, then the next 4 years, we would get a positive value and so on. So again, the abandonment value gives us a picture of the optimal life of the project. What life of the project will maximize the value to shareholders? So that's the end of this video. Look forward to talking to you soon.